and welcome to this solution video. If you like this video, please give it a thumbs up, share this with your friends and subscribe to Math United. Let's get started with question number 1. A curve has y equal to 5 plus 3x minus 2x square. Okay, this is the equation, and straight line has equation this where k is a constant. Find the set of values for k for which the curve and the line do not intersect. So what do they mean? They mean if this is the curve and this is the line, they do not intersect. We should not get any solution if we equate the two equations. Why? Because they will not have any common point, right? So that means I want to not get a solution of if I equate this y and this y. That is 5 plus 3x minus 2x square should not be equal to kx plus 13. So what are those values of k for which this will not have any solution? So what will I do? I'll collect all the terms to one side. To make this minus 2 positive, I will take it to the right side. Then we have 3x and kx. So we will write kx already here, minus 3x will join it. And then we have 13 and minus 5. And let's take this x common here. So, and I will write 0 on the right side now. 2x square plus k minus 3x. This is what we can write. This has 13 minus 5 is 8, positive 8, which is equal to 0. And we do not want a solution for this. And for that, the discriminant b square minus 4ac should be less than 0. The logic is that we have a quadratic formula. This, if the part which is inside the square root, if negative, we will not get any solution because negative does not have a square root. And that's what I've done. Less than 0 means negative, right? This is what I want. So what do I have? What is a in this? This is a, this is b, and this is c. So I'll substitute in this particular inequality and I'll get it. So k minus 3 square, that is b square, minus 4 times a is 2, and 8 is c. And it should be not, it should be less than 0, negative. Yeah. So let's open this one. I'll use this identity, a minus b whole square. It is a square plus b square minus 2ab. So I'll use that one here. A square plus b square minus 2ab. Minus 4 times 2 is 8 times 8 is 64. Okay, so I get what? K square plus 9 minus 6k plus 64 has to be not plus, minus 64. Okay, this will be minus 64, which has to be less than 0. Okay, which becomes again a quadratic inequality. This was quadratic equation. Now we get a quadratic inequality here for k in terms of k. So k square minus 6k, and that will be minus 55 is less than 0. Now you can use a calculator, or you can use quadratic formula, this one, or you can split the middle term to get two roots of this. For finding roots, I will split the middle term. That is the method which is possible here, because 55 has two roots, which is 11 and 5, and their difference is 6. This is how we split the middle term. So I'll write k square as k square, minus 55 as minus 55, and this minus 6k will be 11 and 5, minus 11k plus 5k. So I've changed the look of this inequality. It is still the same. Minus 11k plus 5 is minus 6 still. So what is common in this one? K minus 11, 5, k minus 11. So I get two factors of this, which is k minus 11, which is common, and then k plus 5. Less than 0. So if I convert this to roots, we want less than 0, right? If I want to write the roots, I can make them equal to 0. K minus 11 is equal to 0, then it will be equal to 0 whole of it. K plus 5 is equal to 0, then it will be equal to 0. But we want the negative one. The process is just to find the roots. Okay, I got 2 roots. Now I'll focus on this, which is less than 0, right? For that we have 2 roots, minus 5 and 11. So if I draw a graph of a quadratic inequality where the 2 roots are 11 and minus 5, so let's say this is minus 5 and this is 11, on some scale, I'm not drawing anything else, and it has to be less than 0. Because k square is positive, the leading coefficient is positive. That means this graph, if I draw a graph of this, it will open up, right? When it opens up, which part is less than 0, which is our requirement? Our part is, this part is less than 0, between minus 5 and 11, and that becomes our solution of this inequality, which is that k is between minus 5 and 11. Is there an equal sign here? No. For equal sign, we will have a solution. So we don't want a solution. So k has to be negative, this one, between minus 5 and 11. Which says this is the graph of this particular function. M is a minimum point. This one we can see that. And P is a point whose coordinates are 1 and 0. Means x coordinate is 1, y coordinate is 0. Find the gradient of the curve at P. Whenever they say gradient of the curve, we should read it as the differentiation of the curve, general equation for that. So we'll differentiate this equation. We'll first differentiate this, which is 4x. Then we will differentiate minus 5x. So let me show you. Minus 5x can be written as this. To differentiate this, minus 1 goes in front and multiplies with this minus, so it becomes, I'm saying differentiation of this, so it will become minus 1 times minus positive 1. No need to write, but I'm writing it. Then we have 5 x to the power goes down by 1, so it becomes 5x to the power minus 2, or 5 over x square is the same thing. Yeah, that's what I will write here. So plus 5 over x square is the differentiation of minus 5 over x. Differentiation of 3 will be 0. No need to write. Okay. So now they are asking the gradient of the curve at P. That means at P, x is equal to 1 and our gradient is in terms of x. So we'll just substitute the coordinate of P, which means x is equal to 1 here. Y is of no use as of now. So gradient equal to 4 times 1 plus 5 over 1 square, which is 4 plus 5, 9. 9 is the gradient of curve at point P, and it is evident here. See, can you see it is quite steep here? So 9 could be the gradient. Let's see, we have another part. Yes, find the coordinates of the point M. Give each coordinate correct to 3 significant figures. That means they have already confirmed to us that we will get decimals. So we have to get the coordinates of point M. And since point M is a stationary point or minimum, yeah, minimum is a stationary point, right? Our gradient should be equal to 0. Can you see? If I draw a tangent here, which will be a horizontal line, and the gradient of horizontal line is 0. And that's what I will do. Dy over dx, which is this one, make it equal to 0. So 4x plus 5 over x square equal to 0, and we have to find a solution. I will just put minus this 5 over x square to the other side. That will be correct. Okay, minus 5 over x square when it goes to the other side. Now I can cross multiply. This multiplies, we get what? X cube. So I'm multiplying only x and x square, and 4 will take place of x square equal to minus 5 over 4. And now if we want to find x, not x cube, we have to give it power 1/3 or cube root. So find the cube root of the two parts and we get x equal to cube root of 1/3. Let me use my calculator for this. By the time I do this, I will request you to like this video, share this with your friends, and subscribe to Math United. What I'm getting here is minus 1.083. These are three significant figures, right? That's the coordinates of x coordinate of this particular point M. For y, we have to use the equation of this particular function, which is this one, 2x squared minus 5x. That's what we will use to find the y coordinate, okay, which is 2x square minus 5 over x plus 3. Put this in a calculator and you'll get the y coordinate as well. What I'm getting is 9.963 significant figures. So the coordinates of M are minus 1.08, 9.963 significant figures. Question number 3. Find the complete expansion of this. Complete. That means it has 4 power here. That means we'll get 5 terms. That's called complete expansion. And how does it start? We write the power here, which is 4. We start with 4C0. That's the binomial expansion, right? And then we give the first one, whatever we gave to the number we started with. We usually start with 0, so I'll give it 0. But the other one, the second term with its sign, will get all of it, all of the power which was there. So sum of this and this must be equal to this, and the second number must match with the exponent of the first term of the bracket, and that's it. We'll continue like this. We'll increase the number by 1, this one. So that means 2x will have the power 1 again, minus 3 over x will have power 1 lesser, because the sum of these two must be 4. So one goes up, the other goes down. That is how we carry out the binomial expansion, and this is what I'm going to do here. So 3 terms written already. Then I will write 4th term. So it started from 0, reached 4. It started from 4, reached 0. You can write in any sequence if you want. If you want to write this one first and this one second, that is also fine. So let's start by 1. 4C0 is 1. 2x to the power 0 is also 1. So minus 3 to the power 4. This power will apply with both up and down. So minus 3 to the power 4 is 81. Positive, that is, because it's even power. And x to the power 4. This is second term. Not second term. It's multiplying with 1 and 1. Second term starts now. 4C1 is 4. And 2x to the power 1 is 2x. And this will become be minus 27. That is minus 3 cube over x cube. Alright. 4C2. 6. And then 2 square is 4 x square, minus 3 square is positive 9 over x square, okay, plus 4C3 will be 4, 2 cube is 8. Please keep in mind, we cube the both parts. Do not stop with only x cube. We have to cube the 2 also. Then minus 3 over x. 4C4 is 1, 2x to the power 4. 2 to the power 4 is 16, x to the power 4, and anything power 0 is 1, so it is also 1. So we will write the final part now. This one is 81 over x4 plus, rather it will minus because there is a minus here. This x will cancel with this 3 of them and we'll be left with only 2. So we'll get 27 times 4, which is 108. 27 times 4 and 2 is also there. So 108 times 2, 216. That's what we should write here. 216 over x square. Then x square and x square cancel. 24 times 9, 216. Positive, nothing else. Okay, we have a negative here, so minus 32 times 3, 96. X cancel with 3 of them, so it will be 2 left. So 96 x square and 16 plus 16 x to the power 4. This is the complete expansion of this particular binomial. Moving on, B part says, hence determine the coefficient of x square in the expansion of x square plus 5. So we have x square plus 5, the first bracket, then 2x minus 3 over x to the power 4, which was our earlier expansion. So since I need x square, each part of this particular bracket will multiply with each term of the expansion of this one. So why should I write all of them? I just choose which will give me x square. So if x square is here, what do I need to multiply with this x square so that it remains x square, a constant? That means I'll multiply this 216 with x square. So my x square will multiply with 216. That's it. Now this 5 should also multiply with something which gives you x square. And which of them is giving x square? This one is giving x square. So plus 5 multiplies with minus 96 x square. So what are we left with? 216 x square minus 5 times 96 times 5 will be 480. Yeah, 480 x square. And we'll be left with the 64, 264 minus, because 480 is greater number, x square. Hence determine the coefficient of x square. Minus 264 is the coefficient of x square. Number 4 is about a circular measure where we need to find the perimeter of this shaded region. Okay, so the perimeter is made out of this line, which is 4. So let's write 4. Then this arc CD, then this line, which is again 4 line segment, and this one, which is AB. Okay, so let's find CD first, which is an arc, and we know that arc length is radius multiplied by theta, which is in radians, and luckily we have been given the angle at the center subtended by this arc is 0.8 radians, so we can easily find radius is 6, this one for this arc, and angle is 0.8 radians. That comes out to be 4.8 centimeters. So we got 4 plus 4.8, then 4, and we are left with this AB we need to find out. For that, what will I do? I'll divide this into two particular triangles which are exactly split from half, because it's an isosceles triangle, because both sides are equal. 6 plus 4, 10, and 6 plus 4, 10. So I'm writing 10 here. This is 90 degree. If somehow I find this particular length, which is half of this, I'll double it, and then I will get my AB, right? So this angle, which is half of 0.8, is 0.4. So with the help of this side 10, which is hypotenuse, this 0.4 angle which is there, I can find this. Let's call it y. Alright. So y over 10, which is opposite over hypotenuse, is equal to sine 0.4. So y comes out to be 10 sine 0.4. Since it is only half of the length, I have to double it. So when I want to write AB, I will double this, which will be 20 sine 0.4. So this comes out to be 12.8 plus 20 sine 0.4. Please ensure that your calculator is in radians, set in radians, and we'll get our answer. What I'm getting here is 20.588366, so I'll write 20.6 centimeters. That is the perimeter of this shaded shape. And there may be B part, and obviously they will be asking the area of the shaded region, and let me find it here. How can I find the area of this shaded region? What will I do? I'll find the area of the triangle, because I know the base now, which is 2y, yeah, and I do not know this. Okay, I can use this area of triangle, area of this triangle minus area of this sector. If I subtract the area of sector from area of triangle, I'll be left with this shaded part, right? And for the area of triangle, I will use this formula, half AB sine C, where C is the angle between two sides of the triangle. AB are the two sides. What is the area of the sector? It is half r square theta in radians. Okay, so I'm going to do that. Half AB, I'll take this side as A, which is 10, this side as B, which is also 10, and the angle between them is 0.8. So 10 multiplied by 10 sine 0.8 minus half for this sector, radius is 6, not 10, 6. White part I'm talking about. So 6 is square, and angle is at the center is 0.8. That's simple. So it will be 100 divided by 250 sine 0.8, and 36 divided by 218 times 0.8. Carefully put this in a calculator and area will be found out. What I'm getting is 21.5 and some more digits, but since we want 3 single figures, we will write 21.5 centimeters square is the area of this shaded region. Question number 5 talks about arithmetic progression AP, which has first term 5 and common difference is 6. For this AP, find the sum of all terms that lie between 150 and 400. What they mean is this. The first term is 5, they've given. Common difference is 6, that means the next term will be 11. Then next term will be 17, and so on. There will be some term which will cross 150, right? That term, which is more than 150, plus next, okay, till the terms which are little less than 400 or 400, right? Less than 400. Whatever terms lie between these two numbers, those terms are to be added. So my plan is that if I find n for this and n for this, which term number is this and which term number is this, then it will be easy for me to find their sum. Okay, to find that n, I'll make this equal to one of the terms. 150 will it will not give me a perfect number. It will give me an answer in decimal because it is not a term. Hopefully, it is not a term because they are odd numbers. This is even number. It will not be a term, but it will show me that which term is just before 150, and then I'll start from the next one. So the formula for any term an is the first term plus n minus 1 d. So I'll find for 150 and I will find a 400 also for that matter. So I'll substitute an by 150 and 400. I will get my term numbers. So a1 is how much? 5? Yes. 5 plus n minus 1, 6. So it comes out to be 150 equal, rather let me bring this 5 also to the other side, minus 5 equal to 6n minus 6. When I open this, 6 also goes the other side. 145 is what we get here, plus 6 equal to 6n. 151 equal to 6n. So n comes out to be 151 over 6, which is 25 point something, because 6 times 25 is 150 and point something, maybe 16. Okay, so we know that the 26th term, 25.16, is this term 150, which is not actually a term. So 26 will be the next one. So we have to start from 26th. What about 400? Let's do the same thing here also. 5 plus n minus 1 times 6. 400 minus 5 equal to 6n minus 6. Then 395 plus 6 equal to 6n. 401 equal to 6n. So n comes out to be 400 divided by 6, which will be 6 times 6 is 36, 66 point maybe 66. Okay, that means 66th term is just before 400. Now my plan is to find the sum of all 66 terms, right? And from those 66 terms, I will subtract the first 25 terms. I will subtract them. What I'll be left with? From 26 to 66. Those terms will be left. So the formula for the sum of n terms from 0 to n. This is the formula for us. It is given in the formula sheet for you. Okay. This is the formula. So I will subtract S66, sum of 66 terms minus sum of 25 terms first, which I don't want. And I will get what I want. What are they asking for? So let me do it here. S66 first will be in this formula, n will be 66. So 66 over 2 times 5 plus 66 minus 1 times d. D is also known to us, which is 6, minus 25 over 2 times 5 plus 25 minus 1 times 6. Alright, this cancels out easy. 33. 10 plus 65 times 6 will be 390. 390, yeah. Minus let's say 12.5 here, which is 25 over 2. 10, you can use a calculator. I'm just doing some mental math here. 24 times 6 will be 144 plus. Okay, now this is 400 times 33. 30 times 4, 132 and 0. Minus, it will be 154 times 12.5, 1925. Okay, and 13,200 minus 1925 will be 11,275. This is the sum of all the terms that lie between 150 and 400. Number 6. In the diagram, shows a circle C radius where x is greater than 0 and y is greater than for all points on C. That means they are saying that it is lying on the first quadrant where x and y both are positive. The least distance between any point on C and x-axis is 8 units. Where is the least? This is x-axis, and the perpendicular with this particular bottom point will be the least, and it is 8 units. And the distance between any point on C and y-axis is 5, so this will be 5. No other point is least. These are the points which are exactly normal to the circle. Okay. All right. State the coordinates of the center of the circle in terms of r. So we know that this is radius from center to this point r, and this is also r. So the coordinates of this particular center will be x is what? 5 plus r, and y is 8 plus r. So they are the coordinates of center. Given that the distance between the origin, this point origin, and the center of the circle is 15 units. So this is 15 units, they are saying. Find the value of r. So this becomes a right angle triangle. We know this is 8 plus r, this is 5 plus r, and hypotenuse is 15. We can use Pythagorean theorem here. So 5 plus r square plus 8 plus r square equal to, outside, not with r, with outside, the whole of it is squared, equal to 15 square. That's Pythagorean theorem. So I'll open these brackets now. So it becomes a square, which is 25, plus b square, which is r square, plus 2ab. 2 times 5 times r is 10r. Similarly here, 64 plus r square plus 16r equal to 225r. 225 only. That is the square of 15. All right. So we need to find r. So we will write 2r square now, because this and this are two of them. 10 plus 16, 26r. Then 25 plus 64 is 89. And this 225 comes to the other side. So 225 minus 89. 89 will be 15 minus 9, 6, 21 times 8, 13, 136. So minus 136 is equal to 0. All of them are even, so I can divide the whole equation by 2 so that it becomes easier. So it becomes r square plus 13r minus 68, equal to 0. Now, can I get splitting the middle term and get the value of r? Yes, I can. I am doing this. You can use your quadratic formula for this, no problem in that. So I'm splitting this because 17 times 4 is 68. 17r minus 4r minus 68 equal to 0. R plus 17 minus 4r plus 17. Okay, so r plus 17, r minus 4 equal to 0. Two parts are multiplying and giving 0. That means one of them is 0. We'll equate both of them equal to 0. In both cases, it will give a 0, right? So r comes out to be minus 17 in this case. R comes out to be 4 in this case. The radius cannot be a negative number, so reject it. We got r equal to 4. They said given that, find the value of r. We got the value of r. Do we have another part? Yes, we do. On the point on the circle furthest from origin is denoted by P. Obviously, they are talking about the opposite point to this point. So this is the farthest, this one. Okay. P. Find the gradient of the tangent to the circle at P. So we want to find the tangent to the circle at P. It will be the same tangent which is at this one because they are parallel, right? So tangent will be same. You find here or there, doesn't matter. And I can find this one. So since this is 15 and R we just found out to be 4, that means this line is 19. Yeah, this from origin to the point P is 19. This is 0, 0. All right. So we need to find what are x and y coordinates of P. That will help us in finding the gradient. Rather, can I tell you a logical answer for this? If I take this line and find its gradient, we know the radius and the tangent always make a 90-degree angle. With the help of the gradient of this line, I will find the gradient of that line also. So rather I will find the gradient of this particular line from here to the center. Center is, what are the gradient of center? So the point center is here. So the coordinates of this center are 5 plus r, which is 5 plus 4, 9, and 8 plus r, which is 8 plus 4, 12. So we can find the gradient of this line now, which will be 12 minus 0 y2 minus y1 divided by x2 minus x1, which comes out to be 12 over 9 or 4 over 3. This is gradient of, did I say OP? Yeah, origin and P. But we want the gradient of the tangent. So gradient of tangent will be perpendicular to this, which is negative reciprocal of 4 over 3, which will be minus 3 over 4. Done. A. Show that this can be converted to this. And I'll do the reverse. I will convert this right hand side to the left hand side. Okay, because it is more complicated, I can simplify this to get this one. So my right hand side is 8 sine, let me take something common here. So 8 sine squared is sine 4. So I'll take sine square theta common. Okay, so what is left here? 8 minus 5. Out of this sine to the power 4, 2 are out, so it will be sine square theta here. Okay, so what do I get in this one, which is 1 minus sine square is cos square. Okay, and sine square over cos square is tan square theta. So 8 minus 5 sine square theta, this is what we are left with in RHS. Okay, now this 8, can I multiply this 8 with 1? Okay, and this 1 I can write like this: tan square theta 8 times this one I will write as sine square theta plus cos square theta, which is 1. Yes, and then we have 5 sine square theta. So we are left with what? Tan square theta 8 sine square theta minus 5 sine square theta will be 3 sine square theta. Okay, now cos square theta is alone with 8. Okay, now this tan square theta I got from sine square over cos square, but since our answers are between sine, tan square and sine, and we want only terms, only 2 terms, what will I do? I'll break this 8 into 2 parts so that this becomes 1. So tan square theta 3 sine square theta plus 3 cos square theta plus 5 cos square theta. I broke this 8 into two parts, 3 and 5. What was the purpose? Because 3 sine square theta plus 3 cos square theta will become 1. Means this will become 1 and this is 3 will remain. So tan square theta, 3, if I take common in these two, what will be left here? Sine square theta plus cos square theta, which is 1, plus 5 cos square theta. So tan square theta, this is 1, so we can ignore this one. So 3 will multiply with tan square theta. We got 3 tan square theta, which was the first requirement, plus tan square theta times 5 cos square theta. Okay, it is not matching right now, so we can break tan square again. So 3 tan square theta plus sine square theta over cos square theta, back to where we started here, sine square over cos square, times 5 cos square theta. Cos square theta and cos square theta cancel out. And what are we left with now? 3 tan square theta plus 5 sine square theta, which is left hand side. Yeah. Let's move on to B part, which is hence solve 3 tan square theta plus 5 sine square theta equal to 9. That means they want us to convert this to the right side, equal to 9. So let me solve it here. So I will not write the left hand side, I will write the right hand side now. So 8 sine square theta minus 5 sine to the power 4 theta over 1 minus sine square theta is equal to 9. That's what was there. I will cross multiply first. So it becomes 8 sine square theta minus 5 sine to power 4 theta equal to 9 minus 9 sine square theta. Bring everything to the left side. So I'll write, or rather right side, because so that this minus 5 becomes positive. So I will write 0 equal to, this goes to the right side, becomes positive, 5 sine to the power 4 theta. Then this 8 will become negative 8 sine square theta. We already have 9 sine square theta. Then we have just 9, a constant, positive 9, equal to 0. So now we have to solve this, and this becomes minus 8 and minus 9, minus 17. For solving this quadratic equation, not quartic equation, let sine square theta be equal to x. So what are we left with now? This becomes 5x square, sine square theta square again, minus 8 and 9, 17x plus 9 equal to 0. So we can use quadratic formula for this, which is minus b plus minus square root b square minus 4 times a c over 2a. So that comes out to be how much? 17 plus minus 289 minus 180, 109 over 10. Okay. So if I convert it to decimals, it comes out to be 0.65596. There are more digits after this, which is equal to x. Yeah. But x was assumed to be sine square theta. Yeah. So we'll go back to sine square theta. So sine square theta is equal to 0.65596 square root both sides. So sine theta comes out to be plus minus 0.809919. So we will write plus minus 0.810. No need to write 0.81. Okay. Now we know the sine theta is this, and our domain. What was the domain given to us? From 0 to 270. So we know that sine is positive here, so we'll take plus 0.81 minus positive here again, sorry, and minus here. These three we have to evaluate, these angles we have to find. So sine inverse 0.81 first. So sine inverse 0.81, 8099, let me write 8099, which is 54.08 or 54.1 degrees, that's what I can write. So 54.1 in this direction, 54.1 in this direction, and 54.1 in this direction. These three coordinates, these quadrants will get the answer, 54.1. So the first answer will be 54.1 itself. Second answer will be starting from here till this line, which is 54.1 less than 180. So 180 minus 54.1, and the third one will be 180 plus 54.1. So comes out to be final answers, x is equal to 54.1 degree, and then second one comes out to be how much? 33? No, 23. 120, no, 25.9, and 234.1. These are the three answers for the given equation. Question number 8. A geometric GP is such that second term is minus 120. So second term A2 is minus 120. Sum to infinity is 160. That means R is less than 1. Then only sum to infinity is possible. Okay. Fine. Oh, they're asking common ratio. Okay. So for an, the formula is a r to the power n minus 1. Okay. Where r is the common ratio they are asking. And sum to infinity is a over 1 minus r. We do not know a, right? But if I divide, this is given to us. This a2 is given to us minus 120. So this is a2 becomes ar2 minus 1, or minus 120 is same as ar. Okay. Now sum to infinity is given as 160, so positive 160 equal to again unknown a over 1 minus r. Since we have to find common ratio, we can get rid of a. And how? First I will isolate a here, which is a is minus 120 over r, and substitute here. So I will substitute it here. 160 remains 160. A is replaced now by minus 120 over r, and this r denominator becomes a denominator, a multiplication of this denominator, so it will multiply with the denominator here. Okay, and now we'll cross multiply with 160, so 160 r 1 minus r equal to minus 120. It becomes 160 r times 1, 160 r minus 160 r square equal to minus 120. Again I'll bring this to here so that 160 becomes positive. So it becomes 0 equal to minus 160 r, and minus 120 remains minus 120 because it stays on the right side. Other two change their signs. Okay. This looks complicated, so we can divide it by how much? 40. Divide everything by 40, we are allowed to make it simpler. So 0 divided by 40 is 0. I'm writing it here now. This is 4r square minus 4r minus 3 equal to 0. And that's what we have to solve. And let's see what do we get as r. 4 times 3 is 12 and 6 times 2 is also 12. So I'll split the middle term again. So minus 6r plus 2r minus 3 equal to 0. Let's take 2r common in this. So 2r minus 3 plus 1, 2r minus 3 equal to 0. And then we get 2r minus 3 and 2r plus 1 equal to 0. When two parts multiply and they are equal to 0, that means individually we can write them equal to 0 also. So 2r plus 1 is also equal to 0. This gives me r equal to 3 over 2, which is more than 1. Yeah, this one is r is less than 1 minus 1 over 2, which is okay between minus 1 and 1. So this one is okay. This one should be rejected because it will not give us sum to infinity. Okay, we'll have B part also. We say the first 9 terms of this progression are now removed. Okay, but r remains same. All right. So let me write r is minus 1 over 2. That's what we got. So first 9 are removed. That means A10 is new A1, the first term, right? So let's find A10 first, which is A, R, but first we don't know A. We need to find A first. Okay. Let's find it. So what was A here? This was A. So I can use this one. A is minus 120 divided by minus half. Yeah, minus half, which comes out to be 240. Okay, so 240 is A, and then we can find A10 now. So I'll need to remove this. I know A. So 240 and R is minus half to the power. We want A10. So 10 minus 1, 9. So it becomes 240 divided by 9. So that means negative will remain negative. And 2 to the power 9 is 512. This is A10. I don't want to reduce it because this is not our target. Our target is to find sum to infinity. After this becomes our A1 because A10 is new A1 because first 9 are removed. So what is the formula for S infinity? It is first term divided by 1 minus R, and first term is this one for us now. So we will write it here. 240 divided by minus 512, and 1 minus R will multiply with the denominator 1 minus minus half, which is this, and it becomes how much? 240 and 5 minus 512. 1 plus 1 over 2 is 3 over 2. So I'll write 3 here and 2 I will write here. Denominator of a denominator is multiplies with the numerator. Okay, so cancels 80, cancels 256, equal to minus, and what can we multiply this with? Not 10, 8. 10 and 32. All right, it is again reducing 5 over 16. So finally our sum to infinity is minus 5 over 16. Done. Number 9. The second derivative of a function is this. It is given that the curve has a stationary point at this Stationary point means the differentiation, first differentiation is equal to 0 at stationary point, derivative of tangent. Okay. Use expression this to determine whether the stationary point is a maximum or a minimum. Okay. Since they have given the point, this one, so let's substitute here in place of x, the half, the x coordinate, let's substitute here. So d square y over dx square at x equal to half. What will that be? 6 over half square, no, half, 4, minus 5 to the power 5 over half cube. Okay, so it becomes 6 over 1 over 16, but I will multiply it here. Denominator of a denominator is numerator. That's what we did in previous question also. 5, okay, 1 over 8 is the cube, so 1 over 8, 96 minus 40, which is 56. The value is not important. This is important, that it is positive. Positive means the graph at that particular point to 1 over 2, 9 is opening up, concave up. That means it's a minimum. So we will write, since second derivative is positive, it is a minimum point. All right. Now, so we have second part also. Find the equation of the curve. That's the question. Find the equation of the curve. So, if I integrate d square y over dx square, okay, which is also integration of 6 over x to the power 4. This one, 6 over x to the power 4, but I will write it 6x to the power minus 4. Minus 5x to the power minus 3. Okay. If I integrate them with respect to with respect to x, I'll get first derivative. So it will be 6x to the power minus 4 plus 1, minus 3 over minus 3, minus 5x to the power minus 3 plus 1, minus 2 over minus 2 plus c. That is dy over dx, first differentiation. Okay. Now they have already given us a situation that when it is half, the stationary point dy over dx is 0. They've already given. So to find c, we can do that dy over dx is 0 at, see, let's cancel this one, 2. So minus 2x to the power minus 3 and plus 5 over 2 x to the power minus 2 plus c. Let's substitute the x coordinate half in this so that we get this c. So 0 equal to minus 2 minus, not positive, it's not minus, positive half to the power minus 3 plus 5 over 2 half to the power minus 2 plus c. I'll bring them here. First I will solve this one, which is 4. Half to the power minus 2 will be 4. 4 times 5 over 2 will be 20 divided by 2, 10. So this will become minus 10 when it goes to the left side. This will be 8 times 2, 16, but positive, equal to c. So c comes out to be 6. So our equation, which was this for the first differential, it will become dy over dx equal to minus 2 over x cube, or we can write x power minus 3 also. That's okay, because we have to integrate once more. 5 over 2 x to the power minus 2 plus 6. That's the value of c. But they asked us what? To find the equation of curve. So for finding equation of the curve, we will have to integrate it once again with respect to x. Okay, so dx and dx cancel, and dy, integration of dy is y, which will give us the equation of the curve. Now, minus 2 x to the power minus 3. So it will be minus 2 x to the power minus 3 plus 1, which will be minus 2 divided by minus 2. 5 over 2 x to the power minus 2 plus 1 minus 1 divided by minus 1. So I'll multiply the denominator by minus 1. Plus 6x plus d. I will not write the same alphabet C here. We have to find d. For that, we will substitute the point they have given to us, half and 9. I hope 9. Half and 9, yeah. So we'll just substitute that here. So y is 9 equal to, they cancel minus 2 and minus 2, x to the power minus 2. So 9 to the power, sorry, not 9. It will be half to the power. Half to the power minus 2. Then 5 over 2. And there's minus also, so we'll have to put it minus here. Half to the power minus 1 plus 6 times half plus d. Let's bring everything to the left side so that d remains alone here. So d will be how much? 9. Half to the power minus 2 will be 4, and that will be negative 4 because it's positive here. This will be 2 and 2 cancel, 5. So minus 5 becomes positive 5 when it goes to the left side. And 6 over 2 will be 3. 5 minus 3 equal to d. So 9 minus 4 is 5 plus 5, 10 minus 3, 7. D comes out to be 7. So final equation we get is this one. Y equal to x to the power minus 2, which is 1 over x square. Okay, negative 5 over 2 x, because minus 1 when we bring it to denominator becomes positive x, plus 6x plus 7. That's the equation of the curve. They have given a graph of a line and a curve. Curve's equation is this one, and it is between 0 and 7. The coordinates of P are 7, 0, and they're asking you to find this region A, area of the region A. Okay, so area region A is under this curve and x-axis, so we'll just integrate this and we'll get the area. So integration from 0 to 7, let's write 4 outside, 3x plus 4 to the power half, that is the first term. Second term will be minus 2 outside, x dx, okay, then minus 6 dx. This is what we have to integrate from 0 to 7. Let's look at this one first. Let's give the 4 out. The integration of this, since this is linear, we can simply 3x plus 2, we can simply give increase its exponent by 1 and divide it by the same exponent, increased 1. Further, we'll have to divide it by the differentiation of the content of the bracket, which is 3x plus 4. The differentiation of 3x plus 4, 3. So in integration, we have to do such thing. All right. Then we have minus 2 x square. This x will have x square over 2, and also from 0 to 7. Minus 6, and the integration of dx is just x from 0 to 7. Okay. And now let's simplify this. It will become what? 4, 3x to the power 3 over 2 divided by 3 over 2, so I'll put 3 here and 2 on top, because denominator of a denominator becomes numerator, and this 3 is again there. Alright, and again from 0 to 7. This 2 and 2 can cancel out, so minus x square minus 6x alright. So this is 9, this is 8, so 8 over 9. First I'll substitute 7 in this, so it becomes what? 21 plus, it's not 2, it's 4. Why am I writing 2 every time? So 21 plus 4 is 25, square root is 5, and cube is 125. So 125 minus 8 over 9. Alright, 3 times 0 is 0. 4 to the power 3 over 2 is 8. So 8 minus 7 square is 49, minus 0 square is 0, so no need to write, minus 6 times 7 is 42, minus 0, 42, just 42. Okay, so it can't cancel out, so we can write what? 8, if I take common 8 over 9, it will be 125 minus 8, which is how much? 117. And 9 and 117 will be 13 times 9 is 1, so 13 minus 91. Okay, 13 times 8 is 104 minus 91. So 13 units square is the area of region A. Okay. Find the area of region B. Now they are asking region B area also. So is there a C part also? No. So let's find the area of region B, but I have a plan for that. Since I already know this area now, this is how much? 13. I'll find the area of this triangle. Okay. So area of triangle I'll find out, and I'll subtract 13 from it. The area of this one, because the area under this line, this triangle, also includes A. I'll subtract A from it, and I'll get the answer. For finding the area of this triangle, I know the base is 7, because this length from here to here is 7. We don't know the height, but what we know that the x coordinate of this is 0. We just need to find y coordinate. And how can we do that? That this line is tangent. They've written somewhere here tangent to the curve. This one. This line is tangent at 7, 0. So if I differentiate this curve, I'll find the gradient of the tangent, and then I'll plug in 7 in this, and I'll get the gradient of this particular line. So let's differentiate this. For differentiation, this half comes in front and it becomes 4 times half. So y prime will be equal to 4 times half, and then the bracket remains what it is, 3x plus 4 to the power half minus 1, okay, multiplied by the differentiation of what is inside the bracket. Differentiation of 3x plus 4 is 3. Differentiation of minus 2x is minus 2. Differentiation of minus 6 is 0, so we will not write it. Now we have this particular expression for the gradient of the tangent, but we want gradient at 7 when x is 7, so we'll just plug in 7 in this one. So y prime at x equal to 7. What will that be? This cancel, 2 and 4. So 2. I'll substitute this x by 7. So 3 times 7 is 21 plus 4. 25 to the power minus half. 25 to the power minus half times 3. So I can write that 3 here. Minus 2. Okay. So what it comes out to be 6, which is 3 times 2. Power is minus, so it will go down and becomes square root. So 25 square root 2 minus 2. So 6 over 5 minus 2, which is 10 minus 6 minus 4 over 5. Okay, minus 4 over 5 is the gradient of this line, minus 4 over 5, which will be equal to the normal calculation of our gradient, which will be, let's write y here, so y minus 0 over 0 minus 7. Yeah, so what that comes out to be 28 over 5 and equal to y. So we got our y coordinate here, 28 over 5. Now we have to find the area of triangle and we'll subtract 13 from it. So area of triangle is half base. Base is 7. From here to here 7. Height we just got the y coordinate of this, which is 28 over 5. And minus 13. So 10, 28 times 7 is how much? 56, 5, 90. 196 over 10 minus 13. So it comes out to be 130. So 66 over 10 or 33 over 5 unit square. This is the area of region A, not A, B. Question number 11 and the final one. Function f and g are defined for real values or this, okay, where c and k are positive constants. Given that g inverse is this, show that g of x is this. So g of x means g is the parent function and fx is the daughter function inside it. Okay, so what will we do? Inside this x we'll substitute what is fx. So it will be 2x plus 1, right? 2 in place of x we'll write 4x square minus c. This is how we substitute each x with fx and plus k. So 2 times 4x square will be 8x square minus 2c plus k, which is exactly like this, except that this minus 2c has been evaluated to 1 and we can use this part to get the value of c. Let's see. G inverse 3k plus 1. First we will write, we'll find the inverse of gx. So gx is equal to 2x plus k. So what will I do? I will substitute this gx by y and try to find its inverse. Y equal to 2x plus k, and if we want to find inverse, I will write x equal to 2y plus k. This goes here, x minus k equal to 2y, and y is half x minus k, right? And this is actually the inverse because I have switched the x's and y's. Gx is equal to half x minus k. Now they said that the G inverse of 3k plus 1 is c. So I'll do the same thing. G inverse of 3k plus 1, okay, is equal to c. And if I want to substitute this x by 3k plus 1, I will do it here. 3k plus 1 minus k. 3k plus 1 minus k, okay. So it comes out to be how much? To c equal to half 2k plus 1. Or I can say, if I open this, okay, let's leave it here. Let's put it here now. 8x square minus 2 times half 2k plus 1 plus k. Okay, this cancels. So what do I get? 8x square minus 2k minus 1 plus k. So it is 8x square minus 2k plus k is minus k minus 1. Can you see it matches with what they wanted us to show? Okay, let's go to the B part, which says the curve with the equation 8x square minus k minus 1 is transformed to the curve with the equation y equal to hx by the following transformations. Okay, so translation is 2 plus 3. First we should know how a transformed function looks like. So let me write the original function first. 8x square minus k minus 1. Okay, now I want to transform it. So they want a translation of 2 for x. 2 means positive 2. It goes to the right by 2 units. Whenever something goes right, the x value is subtracted by that. And since x is squared, the transformed part will also be squared. 8 will remain 8, minus k will remain minus k, and minus 1 will remain minus 1. Now, there is a vertical translation of 3. That means y, the whole of the function goes up by 3. And when whole of function we say, we add to the function at the last one. So it went up by 3. Okay. Now, stretch in y direction by scale factor of k. Stretch in y direction means the whole function whole y value has been multiplied by whatever is the factor. Factor is k and it remains k. In vertical direction, k remains k, and we multiply the whole function by that number. Then we want a reflection in y direction. That means whole function will change its y value by negative. Means if it was 5, it becomes minus 5. It becomes minus 3, it becomes positive 3. So we put a minus in plus. So this is reflection, this is vertical translation, this is horizontal translation, this is vertical translation. Let's simplify this now. Minus k hx equal to minus k 8x minus 2 whole square minus k plus 2. Yeah, minus 1 plus 3 becomes 2. This is the function hx. Let's see if we have more. Yes, we have. The range of hx basically is given by h is less than 15. hx is less than 15. So this one is less than 15. Find the value of c and k. So let's open this one first. So it becomes hx equal to minus 8k x minus 2 whole square minus plus k square minus 2k. I have opened this whole bracket so that it becomes in the vertex form of a quadratic function. Yeah, x minus 2 square is quadratic function. What is this? This is minus. That means the graph is opening down, right? They said that the range is less than 15. That means the y coordinate of this vertex is certainly 15. That's why the whole graph is under 15, right? What is the y coordinate in vertex form? This is the y coordinate, which is outside the function. That means k square minus 2k is equal to 15, the y coordinate. And it becomes k square minus 2k minus 15 equal to 0. This is an equation for us which will give us k. So if I split the middle term, it will be 15, 5 times 3. So k square minus 5k plus 3k minus 15 equal to 0. K minus 5 plus 3 k minus 5 equal to 0. K plus 3 k minus 5 equal to 0. This gives us k equal to minus 3. This gives us k equal to 5. And they said if we look earlier, k is a positive. See, positive constant. C and K both are positive constants. That means we cannot take the negative one. So we'll accept the positive one and we'll reject the negative one. So this is our answer for K. Now we want C. For C, we already had an equation here, this one. Let's substitute K equal to 5 there and we'll get K, the value of C as well. Equal to half 2 times 5 plus 1, which was half times 10 plus 1, 11, or 11 over 2. So we got C as well as 5. This concludes our solution video. If you liked it, please give it a big thumbs up and share this with your friends and subscribe to Math United. Thank you very much.